Hello, everyone. I am very pleased to welcome you tonight in the Swiss mountains. We are almost at night. We can say good evening, but for some of you, we can say good morning. I am pleased to introduce our team today to welcome you. You know already Sharon, who is in charge of the techniques for the webinar. She is with Yasmina. And we still have Adam, our North American partner. He will speak to you in a few minutes. And we are going to develop our subject today with John Daniel, who is the Director of Technology in our group, and myself, founder of the company. We are very pleased to welcome you tonight to discuss what we are developing since now 40 years. And we are in the non-destructive technology area. I can say tonight it's a peace conference on non-destructive technology, but applied to wooden poles. And we will see that there is a big connection between new poles and in-service poles in the field. That's why we are going to discuss it. Who we are first. Our objective for today to explain more about our new destructive technology. First will be for wooden pole in the field will be Polux. And Polux, we are at the 5th generation after starting in 93. We will speak about service in the lines and about new poles with LuxPole label and the Silvatest technology, which is a technology I developed in my PhD. It was at the Swiss Federal Institute of Technology in 90. It makes 36 years. Who we are, CBS-CBT, we are engineers, structural engineers at the beginning, but with the research and development, we have developed the non-destructive technology. And you can see I was at the University, Swiss Federal Institute of Technology in Lausanne for 15 years. We develop high span and high building with using timber. And of course, every day we are speaking about wearability, about durability, about safety of the material. And based on that, we have developed this non-destructive technology to help us to manage the quality. We work everywhere on the globe, Asia, North America, South America, and we are pleased to cooperate on Northern America with Adam, and I leave you for your presentation, Adam, please.
Thank you, John. My name's Adam Nelson. I'm the owner of Interpol. We were established in 2010, and we have been closely collaborating with CBS-CBT on the implementation and use of Polux technology in sales within the United States. We're also going to be introducing a new product which hasn't been on the U.S. market yet, which is LuxPole for new wood pole grading. The reasons we're doing this is we've spent a lot of times at trade shows talking to linemen, operations, engineers, and they've all had one common problem is when it comes to pole replacements, they'll get crews out in the field and they'll have zero clue on to why some poles are being replaced. They'll pull them out of the ground and they'll be perfectly fine. They'll also have the opposite of that, where they'll come out to poles and they're so rotted that they're only being held up by the overhead lines. So it's costing utilities millions of dollars each year in unnecessary replacements and then pole failures and the catastrophic issues that come with that. So that's what brings us to Polux. And during this webinar, you'll learn about how these technologies can save your utilities millions of dollars and increase network reliability.
Exactly. Thank you, Adam. We will go later to discuss with your experience. And for the subject today, we are going to start with the technology in the field. And what we are asking for the technology, non-destructive technology, we ask to know the residual strength today. We know that the residual strength today is not the same as 30 years ago. And at the same time, we would like to have a prediction what we can expect as a residual lifetime for this pole, how long we can expect to have this pole in the field. And we will understand that a lot of our problems are coming because we don't have a quality filter with the new poles before to introduce them in the network. And this lack of quality management is the basic problem we have to deal with, even in the field. How it works in the field with Polux? But first, before to develop the technology, we had to understand the systematic. What happened with the pole in the field before to develop ideas about non-destructive testing, to have a statistic of what we have in terms of material. Material is a natural materials, wood is a natural material, and we need to know the quality of this material, and this quality follow statistic law in order to be able to discover an aging process in order to do a better management of our network. And of course, as you know already, it's very easy, and even Sharon can understand that the main problem will be at the ground line level. And based on that, we developed the non-destructive technology, Polux 1 in 93, 33 years ago, and now Polux 5 with much more advanced technology. Of course, we can do a data management because it's a cost. What is the cost? The cost is to go under the line, but when we are under the line, we can take a lot of information, and we develop this complementary information. John Daniel will explain that, and we will conclude with the benefit for you. You know, our motivation, it was quite easy. 93, electricity of France with 10 million of poles in service, and the telecom, French telecom, Orange, French telecom with about 12 million of poles, came to me and tell me, well, with your PhD, you develop an ultrasonic method. I would like to use it for wooden poles in service in order to reduce accidents. We have too much accidents, and we would like to manage it. I say, okay, no problem. But of course, in order to check pole accurately, we need to have a good, efficient, non-destructive technology. And the target will be to reduce emergency situation. And when I started to focus on what is a pole, you see already that the pole need to take the horizontal loads of the wind. We have these loads with the F. It's the bending strength. Bending strength here will be maximum at the ground line, and it's a proportion of the load and a proportion of the length of the pole. And of course, if the diameter is bigger, you reduce the stress. That's basic structure. You have tension on one side, compression on one side. The wind will go making poles breaking in this direction or maybe in this direction. And that's what we were understanding with analysis. And of course, we were starting to break some poles, to break some specimens in order to understand carefully everything happening in the test, why a pole can break with a low bending strength. And of course, we came on this situation we know already for all our material, for all timber material in North America, in Europe, everywhere. We don't have a material with a single value for the bending strength. We have a natural material with a variability. We have a lot of variability, and as I mentioned to the students, with wood, we have one bad news and one good news. Which one you would like? Probably we start with the bad news. Bad news is you have some material with low properties, and it's making difficult to use it as structural element. But the good news is that half of the material, or 2/3 of the material, or 3/5 of the material are very good properties. You can see 70, 80 in place of 10. It's 7 times, 8 times between the weakest one and a strong pole. And of course, the game is very easy. We need to do two things. First, to secure by taking out the weakest poles, and second, make business, make money with the highest quality, because it's a very precious, high potential material. But we need to do this grading. And unfortunately, today, just with your aids, with the inspector aids, is not enough to understand this factor 7 of bending strength potential. And if we look at this picture after in the field, what we see? We see that if that was the new poles in Switzerland, after 20 years, everybody go down, all the family is going down, but suddenly some weaker poles are coming totally red and they are breaking. And we have to focus on this weakest pole. And as you see, if the pole is red or weak since the first day, of course, after 5 years in the field, you will find it, and it will be still weak. And the problem, if we did not the job the first day, we will have this kind of problem in the field. We remark that if actually really the ground line level is subjecting to bring the failure with 80% of the cases, but we saw, and you know it because you are specialized on the material and poles, we saw that it was between 10 and 15% possible breaks up to the ground line level. And what we decide to do, we say, well, the more important is ground line. We are going to do non-destructive technology at ground line, but we do not forget the second part. Iron part will be with the aid of our inspector, with the training of our inspector, and with some criteria to check with the application in order to take into account some particularities in the upper part, in the iron part. Basically, what we need to do, first, we need to have the residual strength. Residual strength is correlated to the material. What is the density of the material, but the local density of the material? I need to know the density as the ground line, because that is the maximum stress and that is the point where it will break. But at the same time, because what is the decay, the aging process of a pole? The aging process is only natural, it's biodegradation. And what happens with biodegradation? It can happen everywhere, in Europe or in America. Mushroom microorganism is going to eat wood. Wood is a feeding, is a nourisher. It will oxidate this sugar and it will produce CO2 and water. When you are oxidating your dinner, you produce CO2 and water. And if the microorganism is producing water inside the pole, it means that we have to measure moisture inside the pole. You see, we saw, you know this picture, we saw it at the first day. We have this outer part very important for the pole because bringing stress, bringing strength, and it's chemically treated properly on 2 centimeters, 3 centimeters. That's very important. We need to have the density of this part of the wood, but the biodegradation will come inside the pole because here is no treatment or not enough treatment after 10 years, after 20 years. And the process, the natural process will start. And here, as you can see, is totally wet. That means with the nail, we are going to introduce 2 nails inside the wood to explore density and to explore moisture content inside. You see on this picture that it can be not symmetrical. You can have a big problem here and nothing here. And that brings us to say we need to do 2 tests per pole. 2 tests per pole, perpendicular to the line, one side, opposite side. And we do that. With Polux, we are connecting the device with a screw in the pole. And then we introduce the 2 nails and we measure here the strength, the force, the compressor force to go inside. When we are inside, we go. When we are inside, we measure by electricity the moisture content inside the wood. The electrodes, the nails, are isolated and they conduct electricity only on the head. It's allowing for us to measure 40 millimeters inside where we have the risk area. And we are looking with the Polux 5 generation, we are looking at all the data, and you can see here that the compressor force going stable, which is quite good, even if it is stable after 30, 40 millimeters, because wood is a little bit less on density. We have the information of the screw, that is the screw energy to go inside, and we have all the data reported here. We know, of course, the date, we know the temperature, we know the energy for the screw, we know the load of compressor. That's more important because we are taking an algorithm to have the residual strength based on that, and moisture content to see if there is decay. I forget to mention with the moisture content, usually a normal pole will be between 10 and 20% of moisture inside. That's usual, that's stable. It doesn't move, it doesn't decay at that time of moisture content. If the decay starts, they will produce directly 40, 50, 60, 70% of moisture, and we will read it quickly. And then, that's very, very interesting, we introduce the nails with an angle in order to have the more negative position we can in the ground line level. And, of course, the Polux is taking like a B technology, will allow us to compute the residual strength, and by ponderation of the moisture content inside, it will be able to mention the lifespan to rest to have for the pole. You saw it in the movie. That's a typical very good pole and with low moisture content inside. And this one is decayed, at least on this side, is decayed with a lot of moisture. Maybe it's strong enough for today because we still have some material on the out part, but we know that the time will be reduced because the process has started. Well, that's basically the technology, and then because we have the software going on your mobile phone, we will be able to record a lot of information in the line. All what you would like to have, we can take it in the application in your telephone. And you will have result in real time. After the test, your mobile phone will tell you what is the residual strength for today, and we will monitor, we will tabulate all the data in the files. Of course, in function of the residual strength and moisture content duration life, we can tell you how long we can be comfortable with this pole. If nothing happened, good wood, high performance wood, no decay process, it can be 10 more years. But if there is moisture, it will be much less. It can be 5, it can be 3. It depends of the residual strength. It's a balance between what you have in terms of material and the moisture process. Benefit of your operation for you. We know that wood is a traditional material and we need the help of the inspector. And we train our inspectors, especially with the diagnostic of the iron part. But inside the wood, only Polux 5 can go. And based on that, we have a very reliable diagnostics. And of course, we have, for example, Deschel, our chief inspector, is 35 years old. He has more as 1 million poles tested with Polux, and he knows exactly what we have to do and what we have to look in a pole when we arrive. And based on this efficiency, on this reliability of the diagnostic, of course, we can save cost. As mentioned, Adam, some poles are old but can still stay, and some other poles are young but not anymore safe and can be a problem for your staff. If we do the management with the NDT, we are increasing the safety and we prevent accident. That's first part with this technology, and I will leave Jean-Daniel express what we can do in the service with all the data management and the other information we can take on the line. Jean-Daniel?
And hello everybody, I just want to present you all our range of inspection services. I will present you the services we decided to propose to our customers in order to give them the benefit of all our experiences using the Polux device and the inspections of overhead power lines and communication lines. Okay, we propose several kind of inspection types. They can be mixed between each other. Okay, so the first one is the asset inventory of the line. So we can give you every part of the line. Field inspection using, of course, Polux device, pictures, identification of the poles. I mean by identification, we mean the univocally identification of each part of the support. Grounding measurements also. We do drone-based aerial surveys, and we have an IT team to assure the data exchange and integration of all the data we collect in the field. We can also give result analysis. Okay, I will go deeper in each of that kind of service. Okay, we propose also software development because we already developed a lot of software for our customers. Okay, by asset inventory, we mean that we can do pole geolocalization. We know that some of asset managers do not have, they have the line localization, but not every pole of every support of the overhead power line. We can do GPS, RTK positioning. This kind of technology can give really good accuracy for the positioning, even in bad environments. We have the experience of that. Our inspectors are also trained to identify the type, kind of pole, the function of each pole, the function of each support, according to all our customers' needs. We can also give you the data of any characteristic of the pole, every characteristic of the line, and do a complete inventory of the equipment. I mean also the insulator types and so on. With the field inspection, of course, we focus mainly on the health of the pole using the Polux device. Our inspectors are really well trained to interpret the result of the Polux device, which give us a really good base to diagnose the state of the pole. Okay, and the benefit of Polux is also that we can have a numeric value of the strength of the pole. Okay, they are also trained to use visual inspection, hammer testing, and screwdriver. All these technology are mixed to give the best inspection of the pole. We also, of course, do inspection of the equipment. I mean, insulator, arrestor, with binocular also, and line defects. Of course, we can give up to the customer all that we encounter in the field. Pictures, photos are really important for the people who are working at the office to know exactly the condition of the pole, the environment, the accessibility of the pole. So for each of our inspection, we take picture as we are in the field. Normally, we take at least 4 pictures. A general view, the identification plate, to be sure that we are speaking of the right pole. The top of the pole, because it's the most important part of the pole, I would say, because you have the insulator, the head, and so on. The base, to know the ground interface and to know the condition of the ground interface. And we can also agreement with other pictures of the body of the pole. If there are woodpecker holes, you can see them very well with our good material to take pictures. Any damage is documented, of course, by pictures, and all notable features and specific condition of the pole is taken in account with the pictures. So the worker, the asset manager, can really know the condition of the pole. We purpose, because a lot of our customer did ask us for that identification. We can put on the pole an univoc identification of each part of the pole, because sometimes support are multiple supports. So with a label identifying each asset part of the pole, we can be sure that the worker on the field will work on the right part. Okay, so we can provide all the labels. We can provide the service to put the labels on the pole with a great accuracy of identification. And of course, we can also remove the old plates to have a good labeling of the supports. We do also grounding measurements, because a lot of our customers asked us to do that, because we are in the field. We organize all the access of the pole and the planning of the line inspection. So we as we are in the field, we can do every things that the customer needs. So we do grounding measurements because a lot of customers asked us. We have our inspector are well trained to use any methods used in the world, I would say. Okay, we have the 62% method and so on and so on. And we can also do a measurement with a clamp-on in a station in other part of the network. Of course, we also propose a drone-based service. We can do that to have a great accurate asset inventory for hard to reach location, for example, or to have a big picture, a great picture with details of the head of the pole or of the equipment of the pole. We can do also aerial surveys to know the vegetation, to look at the vegetation, the pruning, identifying the zone where where our customer have to work on. We can do LiDAR surveys to have 3D modelization of the line, and we do also infrared photography to identify the overhead parts of the insulator, for example. Of course, as we have to exchange data with our customers, we have a lot of experience exchanging data in any kind of file formats. I'm sure we have almost tested everything. So we work with Excel file, but also a direct API, SQL, text file, Esri sheet file, and so on. Okay, that's for in both way. I would say import the data for our inspector to work in the field, and then after to resend the result of the inspection. Okay, we can deliver the data in any way the customer would like to have. I mean KMZ, KML files, QGIS, Esri, any kind of file formats, in addition to the data exchange. We can do also reporting in the format of Excel, PDF, PowerPoint, any kind of file formats, because we have the programmers here to do that for any client, any needs. As Polux give us a numeric value, we can also do a result analysis, an analysis of the network, okay, with finite elements, and we can so give the customer where they have to work for the replacement. We can identify the dangerous zone. We can also propose any kind of replacement by cost, or by needs, by number of poles, or by quality to reach needs. So we have also, with that numeric values, we can also do analysis, I would say, by provider to identify, for example, that year, that provider did not give us a good quality poles, because we know that 10 years, 20 years later, they are weaker than the other one, for example. And of course, at least the software development, we can, because we have all the bricks of the software to do an in-field data collection, so we can do any software development for our customers. We have a lot of poles tested since the first launch of our services. So our inspectors are really well trained, and they have the habit to focus, to know exactly how to qualify the wooden poles.
I am coming in the third part of our discussion before to exchange together. And we have a main issue with Polux when we are arriving with a new client and Polux says this pole is 4 years old but is red. And that's the client say no, it's not a good device because a pole of 4 years cannot be red, is here for 50 years. I say, well, that's a problem. And we come back to the statistic repartition. We come back to non-destructive testing of new material. We need to know before to use the pole, we need to know what quality I have in the hand. And we have developed, it was my PhD, and my PhD is still going on after 36 years because we are still developing with Jean Daniel. By the way, you can see we are really dream team to develop a lot of research and development. And of course, I can show you what we are doing with this technology ultrasonic on new poles. We have to manage the bad news and to valorize the top good news. And we do that in order to have an optimum aging of the network. That is now the ultrasonic probes, one at the top and one opposite side to measure all the quality of the pole. At that time, when the pole is new, the quality is general and is the same everywhere in the pole, a little bit less at the head, but it's everywhere. Is not the case in the field. In the field, the decay will decay ground line. That's why in the field, we need a local NDT, but for new material, we need a general NDT, and ultrasonics is a general non-destructive testing for measuring wood in any condition. We have this variability, you remember, making that we are unable to predict what will be the duration life of the pole and what will be the failure loads. And we will see that new pole can fail in few years, bad news, and we don't understand because it's the same line. You have some pole with 80 years and they don't show any problems. And that is making things special for this material. But that's quite evident. If you look at this picture, that's new pole tested, the same species and the same treatment in Switzerland, 240, it's a large family. What we have the bad news, we have the good news. The bad news is here, the medium is here, and the good news is on the right side, always. And what we have to do, we have to clean it here, filter, and to make valorization with 90% of the family. And how is working ultrasonics? It's very easy since now 40 years. We send an ultrasonic wave in the wood longitudinal, and the time of propagation is directly correlated to the performance, mechanical performance of the material. If it's going fast, it's high potential material. If it is going slow, it's weak material. That's very easy. And we use it every day. For example, here I have a tension extremely important, 60 tons. I need to make a quality control. We make some expertise international like the Forbidden City in Beijing. It's a fantastic building, but for the Olympic Game in 2008, it was a problem. The main column here, behind the building here, were in a wall, and they were decayed in the wall. What did the Chinese people? They open the wall, they look at the wood, they say, well, this one is very good, no problem, we close the wall. I say, well, guys, if you have the appendicit, I don't open your body to see. I take a non-destructive test to do the job before to open. And we came with Silvates Duo 2006. It was still cables, making life less happy. And a few years ago, 4 years ago, you know, everybody knows about Notre Dame in Paris. You see, here you have 6 pieces of wood, 22 meters of oak, one piece. The piece alone cost about 10,000 euros, and you need to have the high performance. Of course, we have to choose the tree before. I have to choose if this tree is good enough for this product, because if it is not good, I am not sewing this beam. I will take another tree. And we were selecting the 6 trees necessary for this 6 special element. And of course, back to poles, what we have to do, we know that with acoustic and speed of sound, we have the bending strength. We have to calibrate the model. We do some extensive destructive tests, and we reach the algorithm given that you see. If you are 6,000 in the spruce, 6,000 speed of sound, 6,000 meter per second, you are totally safe, and it will be a long time material. If you are around 5,000 or less, you are with weak material. It's a lot of difference making able to choose your material at the first day. And what we did, it's very easy. We say red one, 5, 6, 10% out because they are not good. The sawmill can make some games for kids with that, no problem. 50% are with the average quality, and 30-40% are with the top quality. We call it the XL, extra large duration, extra large properties, L and S. And we do the job. It takes few seconds per pole to do the echography ultrasonic and to grade. If I simulate a little bit for you, what happened? You built a line with 80 meters free spine for, you think about 40 years. If I consider a cost to put a pole in the field about 4,000 years, you will tell me, no, it's much more. You will tell me, no, it's much less. Maybe, probably, it depends of the diameter, it depends of the geographic, everything. Just I take 4,000 because it's give an investment of $100,000 a year. 4,000 divided by 40 years, it costs you 100,000 a year. That's your investment, and you expect to have 40 years of happiness. But after 5 years, the first red pole breaks. First one breaks. What you lose? You lose something. You don't reach a target. You are not in the contract. What you lose? You lose 35 years missing times 100. You just lose $3,500 because this red pole, which should be taken out the first day. And that is the main issue. Now, if I take the L quality, I will reach your 40 years, no problem. Maybe no chance. I have one at 35 years breaking. Okay, what I lose? I lose $500 on one piece, but everything is okay. But look now with the XL one, with the highest quality. First, what you have? You have a material much more stronger, which much more residual strength, which much more strength. You can increase 25 or 30% your loads, meaning that you can extend your line. You need less poles because it is stronger. And of course, if you take 20% less poles, you save money. It cost before 100, now it costs only $80 per year as investment. That's the first game. Of course, you say, well, that's a good idea for strategic poles. It can be it can be some poles here. You go with the helicopter. Okay, I will try to put a XL here, not a S, because I would like to have it for 50 or 70 years. Yeah, of course, that gives you a way to manage your quality. But what we discover that it's a correlation between strength of the properties, highest strength, and duration of life. And we are now, after 40 years, seeing that the XL pole are aging very slowly, and they reach twice the average of the species. Twice the average of the species, bringing, for example, here in Switzerland, 80 years. If you build for 80 years in place of 40 years, what you save? You save $80 divided by 2, because it's for 80 years and not more 40 years. It costs you $40 a year. What you make as money, you just save, by this idea, you just save $60 per year per pole, because you manage your quality. That's incredible. It's too nice to be true, like my client says, but unfortunately, that's life. That's when we do not the job. You can see here, that's 20,000 poles in Canada, all species, an electrical network, and we find the red are still here, the medium, and the XL. It's no problem. And we have to hide these red ones. These red ones are already changed. They break after 3-4 years, you know? But look, this quality, XL quality, with this aging process, it will go until here, or maybe a little bit more. That means you have the quality and you have something to do long time, large time duration. In fact, you have two materials. You have weak materials, you have to clean, and you have good, extremely good material you can make valorization. And that's what we do every day. We do it like in Cameroon. We have partner in Cameroon, and probably François Fourier, South Africa, is connected probably. And here in Finland, in the snow, everywhere, any species, any treatment, we will have the family, we will have the distribution like this, and we will cut it red, medium, extra large performances. What we reach, we save some cost, but it's not only a cost effect, it's a reliable effect. Your network is coming more reliable, you have less accident, which is the more important probably, and then if you know it from the first day, you know that this one don't need maintenance until 30 years, 40 years, you know. Here, in 92, in Switzerland, 92, it makes 34 years today, 42 years. We built XL and L poles in a medium line. Today, they are still green. They are still totally green with Polux. No orange, no red. They are still better today as the new one, because it's the new one. I have this family. You see, I am here. I say to our client, well, see you in 30 years. I will not be here, but Sharon will be here with the Polux to measure and to confirm that they are good. You see, that's quality management. It's impressive because wood is a fantastic material, but you have to manage the bad news. That's more or less the subject for today. If I come back on a conclusion before to discuss together, which is the more important, we have a very high natural variability of the wood. It's a bad news, but it's a chance in the same way. We need to do an initial grading, but because we didn't do the job before, today we have some problem in the network. But if we start to do the job, it will be okay. And Polux 5 gives you residual strength, residual lifetime, Service, as mentioned Jean-Daniel. LuxPol, you understand, and I give the floor for Adam, expressing the conclusion with 15 years of partnership with us. Adam, please.
Yeah, great presentation, Jean-Luc. One thing I did want to touch on quick. I know you had mentioned the resistograph, and there's one other thing that the resistograph in Polux differs. A resistograph isn't able to detect bad poles that don't have any internal decay. It'll show that there's material all the way throughout the pole, but it doesn't tell you how good the material is. With Polux, we can tell you the density of that material. So that's another thing that keeps those, or has them, that makes them different. Yes, as Jean-Luc said, we've been using Polux technology in the US for about 15 years, and we've had great success with this device. Our best, I guess I would say our clients would probably be our best references for this, as once they've discovered Polux, they've been very happy with it. So.
Amazing. Thank you very much. So this will be our last question for this webinar. But if you have any other questions, please feel free to send us an email or send Adam an email if you want to know further about the Polux technology, the LuxPol services. It was, I think, a pleasure for all of us to be able to share all this information about this technology that we really wish to share with everyone.
Thank you, everybody. Thank you, our team, Jean-Daniel, Adam, Yasmina, Sharon.
Thank you. Bye-bye.
Thank you, everyone.
Bye-bye.
Bye. Have a nice day, everyone.